Hello everyone. Today we'll explore how to train a neural network model using your very own voice in open source project Wunjo AI. Firstly, we'll prepare the appropriate dataset for training. Earlier, I recorded my voice using the Audacity program. For a recorded voice, we must ensure that the project's sample rate is 22,050 Hz. If you've recorded in stereo, then you'll need to downmix the stereo channel to mono. As a result, you might also observe a bit rate of 352 kilobits per second, which you'll achieve if you save it with Sines, 16-bit paint and kitting. Next, we'll eliminate any silence at the start and finish of each track. Please refer to the command displayed on the screen for Linux. After processing the audio, ensure that the file name corresponds to both the content and the entry in the annotation file. You might also observe plus signs in the annotations. These plus signs distinctly mark the stressed syllables in words. However, if you're without a dataset and are eager to start training, consider using the open source speech dataset. The link is displayed on the screen. So, in order to train a neural network on a dataset of speech dataset, the model, ensure that video cue drivers are configured. Additionally, download the advanced extension from the Wunjo AI application. If you have a cue set up for the app, you'll notice an option to toggle between cue and cue. Switch to cue mode and click on the brain icon. In the ensuing panel, you'll find options to train both the tacotron2 model and waveglow. When the extension downloads, you need to reload the application, and you will see the new icons on the panel. Open the voice training panel. We'll initiate training using the tacotron2 model. Input the path for the markup file, as well as the audio files, and then commence the training. If you wish to continue training from a previously trained model, select its checkpoint and provide the model's path. I've earlier sanitized the markup file, eliminating any duplicates. Now, choose English as the training language. As shown in the video as in because RU means Russian language, but our dataset has English mark text, and then click on Train Tacotron. The training will commence after a brief moment. To monitor the training progress, click on the console icon. After the training is complete, navigate to the Wunjo's trained voice directory. Inside, you'll discover folders named by dates, representing the trained models. Each folder contains modal checkpoints, with the last checkpoint representing the final training outcome. Additionally, you'll find a YAM file detailing the training parameters, along with markup files separated into test and training categories. However, while training, you might face an error indicating insufficient memory for the process. In such a case, navigate to Wunjo Extension's Advanced Static Config Tacotron Params YAM and consider reducing the batch in the parameters, adjusting it from 32 down to 16 or even 8. Now let's train the waveglow model. Typically, you can simply fetch this model from the Wunjo voicement directory for a Russian voice or Wunjo voice English woman for an English voice. However, if you prefer to train it on your own, ensure you select waveglow during the training process. Once the voice training is complete and you want to utilize it in the Wunjo app, you'll need to navigate to Wunjo's trained voice and integrate it into the custom user file. Let's walk through this. First, Refer to the default settings provided in the guidelines and then input the paths to the models. It'll be incorporating the path for the trained tacotron model along with the finalized waveglow model. Let's evaluate the outcome. As evident, a new voice has been integrated and it's operational. I trust you found this walkthrough beneficial. I look forward to seeing you again at Wunjo AI.